So you kind of stumbled into this by happenstance. It sort of, at first it seemed like it was food restriction that could be driving this effect on the kidneys, preserving kidney function, not progressing in the disease state, but it was actually ketosis. So you can do intermittent fasting to induce ketosis. You can give them a ketogenic diet to induce ketosis without restricting their calories, and you get the same result.
That's exactly right. And then someone in the lab even suggested, the main ketone that is made during fasting is called beta hydroxybutyrate, or BHB. That's normally made by the liver. So somebody in the lab said, why don't we just feed these mice the beta hydroxybutyrate and see what happens
on a non-ketogenic diet?
Right, exactly. Just on a normal rodent chow. And, rodent chow is always a very high carb diet. So again, I wouldn't have thought this would work, but I said, okay, fine, go ahead and do it if you want. And it turns out it actually worked. So you could mimic the benefits of a ketogenic diet by just simply supplementing this one ketone in the drinking water. I just put BHB into the drinking water, and you have the same kidney protective effect. So that was pretty striking, and so we published all these results, and the paper actually made a big splash in the field. So people started to wonder what's going on, and has sparked a lot of clinical studies now also.
So it looked at first like calorie restriction was having this beneficial effect for the kidney. It turned out that it was the induction of ketosis, which you can do either by restricting how much the animal eats or when it's eating, or by giving it a ketogenic diet, a high fat, low carb diet, or you can do it without ketosis, basically. Without a ketogenic diet, you can simply give BHB in the drinking water, giving them an otherwise fairly high carb diet, and you get the same effect. So it's BHB in particular that seems to be driving this.
Right, exactly. So now the question is still, what does BHB actually do? And that's something we have been working in the lab. But on the other hand, if something as simple as BHB has a beneficial effect, who cares why it's working, right? Essentially,
clinically, maybe you should just be giving certain people with kidney problems BHB.
Right, and that's actually what we ended up doing. So as you may know, BHB in the US, you can buy it as a supplement. It's fairly inexpensive. You get it on wherever, Amazon, in all kinds of different products, and people. People with PKD were emailing me and saying, "Hey, which BHB product should I buy?" On Amazon, and I always told them, "Oh, wait a second, these are supplements that have all kinds of other stuff in them. I can't recommend any of them." But a group of people that I knew that actually had PKD and were sort of industry professionals, we came together and we decided to launch a company, so a startup company out of the university, to essentially put something together that is kidney safe and contains beta hydroxybutyrate, and is something that we could recommend, and that's exactly what we did. And we actually sort of made use of the fact, so we had another sort of discovery in the lab, but we had started out by talking about these microcrystals. And what we found is if we actually inhibit microcrystal formation, you can greatly improve the progression of polycystic kidney disease, again, in these rodent models. And the best way of inhibiting calcium microcrystals is by supplementing with citrate, citric acid. And the reason is that citrate is actually the natural defense of our kidneys against calcium oxalate crystal precipitation. Because the citrate, has can chelate calcium, so it kind of wraps itself around the calcium and prevents the calcium from ever seeing the oxalate. So it prevents the calcium oxalate formation, which means the kidney can then harmlessly pee out all the oxalate and all the calcium without ever forming calcium oxalate microcrystals. And of course, and we can do this in animal models. We put the citrate into the drinking water, and it greatly improves a PKD progression. But then we said, all right, so citrate works, BHB works. What if we put them together? So we combined them, and we found that we actually get a synergistic effect. So you get away with a lower dose of beta hydroxybutyrate and a lower dose of citrate, and you still get the full protective effect. And that allowed us to actually, file for patent, for the university and say, hey, there's synergism here. And that, gave us the chance to actually launch a company based on this technology.
Mm-hmm. And is there anything different? So is it just plain citrate and plain BHB, or like, is there any difference between what you've made and, if you just had a bag of BHB and then you had a bag of citrate, could you just take one scoop of one and one scoop of the other one?
You could, but we formulated it in a kind of like a smart way, if you will. So BHB, there's different forms of BHB that you can administer and buy. Maybe the simplest form, if you will, is the BHB salts. So beta hydroxybutyrate is actually comes from beta hydroxybutyric acid, and it's an acid, and you don't want to necessarily drink an acid all day long. So the form that is in most supplements is something like sodium beta hydroxybutyrate, right? So you have a sodium salt. But sodium, on the other hand, is bad for kidney disease. If you there's already very strong correlations with between sodium and kidney disease. So we wanted to make sure to make it sodium free. And most of the supplements out there are actually sodium BHB, which is one of the reasons why I couldn't recommend those. So we spread out the cations between potassium, calcium, and magnesium. And sodium free. And the reason for potassium, calcium, and magnesium is that most people are actually relatively deficient in all three. So lots and lots of people in the US are magnesium deficient. That's like one of the most common electrolyte deficiencies. Same for potassium. Most people don't even get nearly enough potassium in their diet. And actually the same for calcium. And then the calcium, if you ingest it, like we said before, it can actually neutralize oxalate from the food. So it kind of acts as has a double beneficial effect if you formulate a product with calcium in it. And then the citric acid, essentially comes in the form of just plain citric acid, and we formulated everything to. And it might be too much detail, but we made it so that it delivers what's called 50 milli equivalents of alkaline base. So you essentially add a little bit of alkaline base to your body, and that can help overcome the acidosis that is very common in people with kidney disease. So most people with kidney disease produce too much acid in their body, and the acid has to be excreted through the kidneys. And that makes it so that you end up with a very low urine pH. So you kind of have, a pH of 5, let's say, all day long. And the low urine pH is also, it's not a good thing for the kidneys because it facilitates the crystallization of uric acid microcrystals, and it also facilitates calcium oxalate microcrystals because it inhibits citrate. You want to alkalinize the urine, and that's what the formulation helps to do.
Is this formulation out and available now, and what is it called?
Yes, it's out. It's been on the market for I want to say 3 years-ish or so, and it's called Ketocitra. And so you can probably guess where the name comes from. The keto part is the BHB part, the citra part is the citrate part.
So that's CITRA.
CIT, yes, right, exactly.